Hello everyone, I'm Wang Zixuan, a TA for Operating System, and I will be responsible for Tutorial 8. In this video, we will provide a detailed explanations of all the questions in Tutorial 8, and I hope you find it helpful. Before we begin, let's quickly go over the entire Tutorial 8. We can see that the whole tutorial 8 can be divided into three parts: the memory allocation, paging, and the segmentations. For the uh, for save the time, we just use a PowerPoint. I gave all the problem in the PowerPoint, so we don't need to change the tutorial PDF fields. So for the first, let's start with the first question on continuous memory allocations. Uh, just like the problem said, we have the total memory size of 5,000 K. And there have a list of four hosts of this, and the request sequence is just like this, and the problem let us use the three kind of uh, allocate algorithm to deal with this problem: the first fit, the burst fit, and the worst fit. So for the total size is 5,000 K, and there is a four hosts, which means and if you count all the hosts memory, you can get almost five, five, 500. So which means they already have 3,500 to be used. So So before we start to do the detail, let's give a brief review about the three kind of algorithm. The first fit algorithm allocates the memory to a process by scanning the list of free partitions from the beginning and selecting the first available block that is large enough to satisfy the request. Remember, we need to choose the first available block. And the best fit algorithm searches the entire list of the free blocks and allocates the smallest available block that is large enough to fulfill the memory request, which means you need to find the smallest block which can almost put the request here. And the worst fit algorithm allocates the memory by selecting the largest available free block that can satisfy the request. So this is the answer. Now we will give you the detailed explanation of all three kinds of the algorithm. For the first one, we can see that uh, in the first fit algorithm, if 280 arrived, you will try to put it to the whole one by one. For the first one, because it's only have a 200 memory, so you can't put it here. So you just put it to here. After see 208 requests, you only have the 120. So when the 180 request when the second request arrived, you need to go back to the beginning of the sequence to try to find mm, which one is reached the request. For the first one, there is a 200. You know, this just satisfies the request, so you can put it here. After receive the second request, the first hole only have 200. So when the third request arrived, uh, the first hole and the second hole is not satisfied the request. So you can just put it in the third in the third hole. But after you deal with the third hole, you only have 208. So when the fourth request arrived, all the four holes don't have enough space to save it. So we said that the first the fourth request is not satisfied. So so we ignore the fourth so we ignore the fourth request and just repeat the schedule. We can see that the the fifth and sixth you can put it in the different holes. So just like this problem told us, we need to calculate the utilizations. Just like I told you, uh, there have four holes like 200, 400, 600, and 300, which means there already have 3500 memory just to be used. So the utilizations you can calculate just like the memory already be used and the memory you just allocated. So and you count with the total size of the memory. So you get the utilization. So after use the first fit algorithm, we use the best fit algorithm. Just remember the best fit algorithms. It means you need to search the whole sequence, find the smallest one, which can be deal with the request. So we can see if the first request just arrived 280, we just put it in the last hole because first hole you can't. First hole don't have enough space, and the second hole and the third hole. For the second hole, if you use second hole to put the 208, they already have almost 120. For the second hole is more larger, but the fourth hole only have the 20. So this is the best fit means. So just to follow this strategy, we can put all the sequence just for these holes. So after the second request arrived, the whole sequence just show like this. We can see that uh, if you put if you put the second sequence in the first hole, uh, the last memory is small, so you can put it here. So when the third request arrived, you just follow the steps by the first and second, you can put it here. So it's likely by this strategy we can deal with 400. So because we don't save any request in the third hole, so third hole have enough space to deal with the fourth request. So we can put the fourth request here, and the fifth request we can put it here. But unfortunately, when the last request arrived, all the hosts don't have enough space, so we can't put the request to any host. So the not satisfied memory is this. So just like the previous thought, we can calculate the utilization just like this. So the whole utilization rate is 96%. So now let's go to the last one, the worst fit. The worst fit algorithm, the point is you need to find the large. Larger is better. So when the first request arrived, you need to search all the whole sequence, find the largest one to put it. So you find the third hole, the and after you deal with the first request, your whole request will be updated like this. So when the second one arrived, you will put it in here. So just to follow these steps in the fourth, the same problem just rest like the first fit algorithm. You can handle the fourth request just like this to us. Uh, and the fifth and the sixth request you can easily to handle it, just like put it in the uh, fourth hole, put it in the second hole. So the authorization rate it seem like it seem like it's equal the first feed, because you only the not satisfied memory is the same is 400. So after we use all the three algorithms to answer this problem, there are still have another problem, just like which is the best, which is the worst. I think it is easy to find that the best fit is the best because the authorization rate is higher, and the first fit and the worst fit is the same. And the last question is user compaction. Could you satisfy all the requests in the three algorithm? What is compaction? Compaction in memory management refers to the process of reorganizing dynamically allocated memory blocks to reduce external uh, fragmentation by consolidating free memory into the single continuous block. What that means? After you put all the requests in the different holes, there still have a little space to be empty. So what you do is you need to do some ways to merge this little space together. So let's come back to the first one. After the last request be solved, what we have? Uh, we have the sequence like this of so you need to use the 280 to minus 160. So um, the all the small speeds you can be added together. It's just like 440 uh, like this. So if you merge them together, you can easily to handle the fourth request. So for the first feed, it's okay, and the first feed and the best feed. So we back to the best feed. So the best feed it's same. If you add them together, you can find that the speed is 200 and the request just need to 160. So it's also good. For the last one, the worst fit, we can see that you also have 400 need to be processed, and you have the 200 plus 180 and plus almost 60. So it's 442. So it also can be saved by this. So let's go to the second problem. Second problem is more continuous memory allocation. In this case, we have a long sequence, but the hole is only have a three holes. And how to because we in the first problem we give the detailed explanation of the first fit algorithm, best fit algorithm, and worst fit algorithm. So in this problem, we will uh, ignore them, just to give you the direct you know, just to give you this table. By this table, you can easily to find how to put the sequence in which holes. Uh, so I will take you like a quick go through. For when the first one arrived, because it's the first feed, the first hole is 100, so you put it to here, and 100 be the 69. So just follow these steps. Uh, mm, when the last sequence, oops, there is wrong. We also have a 18. So when the 27 request arrived, because all the holes you can see here, don't have the enough space, so this request will be denied. So after the last one arrived, you can be put it as this. So the remaining whole is like this. So the authorization is same because in this problem the total size is 1000. So and the whole is 100, 108, and 120. Just remember that the whole means the other part of the memory is be used. So you need to plus it. So you use the 1002 minus 100. Oh, oops, there also have some some loss. So this will be red and minus the memory you allocated. So you can get the utilization is 98.3%. So let's see the best fit. The best fit algorithm is just like this. So for this long sequence, you need to put you need to put all the requests in the different hole um, and count the still and count the last space. So we won't repeat the sequence and we just talk about the special case. When the 49 arrived, we can see the last column. We can see that three the three holes just like 35, 40, and 17. So the 46 will be rejected. So this is unsatisfied case. So just remember this, we can count the utilization is 96.4%. The last one is the worst fit. So we don't waste a lot of time on here. Just like this chart, like this table. You can do it step by step, and you can get that when the last when the when the latest two requests arrived, the three who also both don't have enough space to deal with them. So these two of them will be rejected. So will be rejected. So authorization is just like this. So see the last problem. What are the authorization for the so we just count them. So which is the best and which is the worst. So just to see we can find it easily. When we use the first fit, the authorization rate is higher. So the first fit algorithm is best, and the best fit algorithm is worse. So user compaction could you satisfy all the requests in the three algorithm? It's different with problem one. In the problem one, when we merge the small space of each host together, we can handle the unsatisfied request. But in this problem, we can see that uh, the remaining host is just like 8 and 9. If you plus them together, you only have a 17. You only have 17K, but the request is 80K, so it's not satisfied. Although you merge them together, so it's unsatisfied. For the best fit situation, we can see that the remaining holes is 8, 22, 22, 6. When you plus them together, you can get 36. But just like this, the rejected request is 46, so it's still unsatisfied. The special case is the last one, the worst fit. Do you remember we just rejected two requests, 207 and 18. So we can see that we have lots of space remain together, just like 14, 5, 16. If you plus them together, you can get almost 35. You can put this request to it. You can put this as individually. But if you put them together to the space is not enough. So in this case, we also treat it as not satisfied. So let's see the next problem. The next problem is paging. So this problem is almost about the paging. They give a lot of concepts of the pagings, so it's easy to answer. For the subproblem one, subproblem A, what is the length of the logical or virtual address? So in the problem, they gave some hint. They said the size of the logical address space is 32 MB, and the size of page is 500, 512 bits. The data is stored in the physical memory of size this. So for the subproblem A, uh, a a 30 a 32 a 32 MB a 32 MB logical address space requires almost 25 bits because just like we can see that um, the the 32 can be used to power 25. So if you use the bits to replace the address space, so the length of the bits will be 25. And the second sub problem is the physical memory has a size of this. Just like you need to do some math problem, you can easily to find the two power 18. You can get the to 500K, and the length of the physical address is 8 bits. And the pages is 512. The 512 can be calculated by the 2 power 9. So the length of the offset is 9 bits. And then, uh, what is the length of the page number field? The page number field is means uh how many bits you how many bits will you use to represent the page number. So because we just know the m is the logical address, and the n is and the no, no, this should be wrong. The n is the answer of the page number field. But if you want to count this, you can't use this will be wrong. So you need to use m minus another one, m minus the page size, because because the logical virtual address const can be divided in two parts. The two part is the first part is a page number field, and is the second part is the second part is the offset field. So you use 25 to minus 9, you can get the page number field. So just remember the virtual address virtual logical address is consists of two parts. The first part is a page number field, and the second part is offset field. So the last question, how many frames are there in the main memory? We can see that the physical main memory size is this, and the page size is this. So if you use If you use the main memory size to do this, you can get the number of the pages. This question tests the understanding of address space partitioning. Logical address split into page number and offset, while physical address use frame number and offset. The key takeaway is how page size and memory size determine address bit length. So in this, I will give a hint to this. So the uh, logical logical the logical address is offset minus plus offset plus page number. So we see the next question, page table and memory frame. So the problem is consider a process P that occupies 5 pages, page 0 to 4, storing contents A, B, C, D, and E respectively. And there have 7 free frames available in the memory, maintained by the operating system in the frame number order like this. The first assignment, you need to draw a diagram to indicate the content of a frame under the page table after all the 5 pages of P. So for the given page table and the logical address, we need first to calculate that. Just remember the previous mentioned. The logical address is this, and the page number is P. So we can get this. When you cut them off, you can get the you can you can get the offset. Offset is this. This is offset. This is page number. So if you want to put the frame 11 to here, you need to use the 11 frame to minus page size and plus the offset. So we can get the physical address would be this. So if you want to, we can see that you draw the diagram and you put this in this sequence A, B, C, D, E, and the page table you can be put them like this. Just follow this sequence. And how to you to allocate the memory when you see the 42 pages, you need to calculate the memory address scope. You can see that you use page number 42 to minus the size of the frame. The size of frame is 1024. So and the address group will be like this. So you in the physical memory and it's bigger, so you put them down, and after 42, you get the 11. So just follow this uh, follow this sequence. You can put all the physical memory just like this. So so there are 6 bits for the frame number. So there are 2 power 6, which is equal to 64 frames in the main memory. Because in the memory, they told you there have 6 bits. So each frame have the size of 1 KB, same as size of the page. So the main memory is the total page number to minus the page size. So it's 64 minus 1 KB. So the main memory is this. So let's see the problem 5 segmentation. This is a segment number, and this is the base. This is the length, and the problem gave you you can see this is a sequence 2. They give you a sequence like this the left part is indicated the number of the segment, and this part is indicated the length the offset of the segment. So, how do you do this problem? Kind of, I summarize the steps like the 3 steps. First one, you verify the validity of the segment number. Confirm that the segment number in the logical address exists in the segment table. And the second one, you need to check the legality of the offset. The offset must be less than the length of the corresponding segment. Otherwise, a segment fault will be triggered. And the third one, you need to calculate the physical address. And the physical address is base address plus the offset. So from the follow these steps for the uh, for the A for the subproblem A, when the segment 0 arrived, the offset is 400 and CT, and the base is 200 to 219. So you need so the physical address is you need to use 219 plus 430, which is this. And the second one is segment one. When the segment one arrived, the offset is 200, but the length, but the segment in the segment the table, the length only have false. So this one will be error. So when the segment 2 arrive, the length is 100. We can see that in the section C, we can see the offset is 30. So it is satisfied. So you can be calculated the physical address. Just use the base to plus the offset. Is this for the D? The D the segment 3. The segment 3 is this. The base is this, and the length is this. So the length is bigger than the offset. The offset is 400. So you can be calculated the physical address about the segment 3. So you just use the base and plus the offset. You can get this for the last one in the segment 4. For the segment 4, the length is 96, but the offset is bigger than the length. So this one will be rejected too. So it's also be an error. So let's see the last question, the question 6. Before we start the question 6, let's go back the question 5. So just remember the step. If you want to do the segmentation, you need to follow these 3 steps. So just see them again, and we go back to the last questions. The last question is you need to combine the question 5 and combine and the question 6 together. They said that suppose the segment 2 of P1 in question 5 is an array for greater information to be shared to another process P2, which has a first segment of size for its program. A second segment of size is this for its global variable and file. So just we can ignore. So a just to summarize the problem, we can get the physical memory is like this. We got the 4 KB, which means we from zero, the scope is 0 to 4095, and the used segment is this. It's just like this. Mm. And the available memory is this. So we can, based on the problem, we can summarize this table. Segment number is this, and the base is this, the length is this, the scope is this. So it's easy to it's easy to count. You just use the base to add the length. You can get the scope. It's very easy. So we will ignore this. So after you get this table, we can get the free blocks. Free blocks is this because in the problem we can see that lots of them are be uh, we need to see this for this lots of segment have the is from the different part. So for the problem, we can get the free block is this. So the free block, we can be treated them like the host. So the whole sequence will be just like this. And the process tools requirements is a segment zero. And the size of the segment zero is this. Segment one is this, segment four is this, and the segment two is shared, which means process one, process two both need to this segment. So for the first fit, we need just turn this problem to reduce to the first problem. We need to find the sequence. The sequence is this. Uh, the size, and this is a segment number, and this is the size. We can see that the sequence is this, and the host, we just follow this, we can get the host number. So if you draw the first fit algorithm, we can get that when the first segment arrived, you need to allocate it in the last host because only the last host can satisfied with it. When the second one arrived, you need to put them to the third hole because just remember, although the last hole can solve the request two, but this is the first fit, so you need to put them in the third hole. And when the last request arrived, all the previous hosts can't handle it, so you need to put them in the last one. So after we use the first fit algorithm, in this turn we use the best fit. Just remember the best fit, you need to find the satisfied host which the last memory is the is smallest. So when the first request arrived, the 781 arrived because all the previous hosts cannot satisfy it. So the only way you need to save it is just to put them in the last hole. So after you save the first segment, the whole sequence will be just like this. So when the second request arrived, you put them in this one, because if you put them in the last one, the last memory will be larger than when you put it into this part. So it's just seem like the problem one. So in the last case, you just put them in the last one. So the last part, the worst fit, just follow the same as first fit case, because uh, when the first request arrived, only the last one can handle it. When the second request arrived in 500 and 700, you must to choose 700 because this is a requirement of the worst case. So based on this, we can get that the first the first fit algorithm and the last and the best fit algorithm is the same, and only the worst fit algorithm is different. So let's go back to the problems. So when we use three kind of algorithm to do this, and the problem let us to determine the physical address by performing the five logical address translation as in question 12 of the three column. Uh, so in this part, we need to calculate the physical address for all for the P2, and just based on the scopes, we can get this. If you put we use the worst fit case as an example. In the segmented zero, if you put a segmented zero in the whole six, the whole six scope is this. So the base address is 2000 is 2314. So you just so the address is you need to use the base to add the offset. So we can see that the number is this. Because in the three types of the algorithm, we both put the first request in the last hole. So for the segment zero, the start address is the same. The physical address is the same. And for the segment one, because FF and BF is the same, so we can go back to the FF. FF, we can see that when the second request arrived, we will put them in the third hole. The third hole's base address is this. So you need to use this to plus the offset this. So you can get this. This is the physical address of this. So for the segment two, this is a this is a shared segment. So the address is settled. It's just to be allocated from this. And the segment three is this. So for the different algorithm, you just need to check this point and check the scope and just remember plus the base and plus the offset, you can get the physical address. And for the segment four, just to remember the segment in the situation of the segment four, because offset is larger than the length of the is larger than the length of this, so this will be rejected. So this question cover KOS memory management concepts, allocation strategies, paging, segmentation, and sharing. Understanding this principle is critical for optimize memory utilization and ensuring efficient process execution. Thanks for your listening. If you have any problem, you can find me face to face or just email me. Thank you.